minus 3x minus 2y.
All right, so you're going to get these four terms, and then you're going to combine your like terms. So which of these can I combine?
14x minus 3x, 11x.
All right, so 2x squared. What's 14x and negative 3x?
11x.
Plus 11x.
And then minus 21. Okay? Now, you're going to go backwards. When we start doing this, when we start factoring this right here, you're going to have to give me these two binomials as your answer. That's factoring. Remember, factoring means to write as a what? Product. So notice that this trinomial I wrote as a product, didn't I? A binomial times a binomial. That's a product. All right. Number 6. Suppose you had 3y minus 2x times 4y minus 5x. So 3y minus 2x times 4y minus 3x. Okay, so I want to multiply this out. Now notice it's a binomial times a binomial, so I can use the FOIL method. So FOIL. So the first, do it in that order first. So the first would be 3y times what?
4y.
12y squared.
12y squared. Any questions? Okay, the outer are the outside terms. So that's the 3y times a
negative 5x.
negative 5x. What's 3y times a negative 5x?
Negative 15xy.
Okay, negative 15xy. Put them in alphabetical order. xy. The inner terms are the terms on the inside.
2x times a 4y.
So it's a negative 2x times a 4y.
Negative 8xy.
Okay. And then the last will be the last terms of each binomial.
Negative 5x.
So it's a negative times a negative.
Positive 10x squared.
Okay. And then combine like terms, what do you get? I can combine these, right?
Yeah, negative 15 minus 8, which would be
Negative
negative 23xy.
Plus 10x squared.
Plus 10x squared. Okay. And so you're going to have to end up going backwards at some point. That's probably the second lesson after, or the second section after this one. All right. Now, what if you had this? This is going to be number 7. Number 7, you have 2x minus 5 squared. 2x minus 5 squared.
Write them out as the 2.
Okay, so remember 2x minus 5 squared means 2x minus 5 times what?
Itself.
Itself. So you need to rewrite it out as two binomials. So 2x minus 5 times itself. So you're squaring a binomial. So I can just use the FOIL method. And so 2x times 2x is 4x squared. The outer is
Minus 10x.
the inner is also a
Minus 10x.
yeah. So remember when you square a binomial, the outer and the inner better be the same. And the last, what's a negative 5 times negative 5?
5 is positive 25.
So 4x squared minus 20x
Combine like
plus
terms.
25.
All right. Okay. All right. Now this right here, if you recall that this trinomial, when you get this, that's called a perfect square trinomial. Just go ahead and write this down for right now. That's called a perfect square trinomial. And the reason it's called a perfect square trinomial is because you got it by doing what to this binomial? Squaring it. Squaring it though, right?
Mm-hmm.
Squaring it. So perfect square trinomial. So you square this binomial, you ended up with a trinomial. So this trinomial is going to be a perfect square trinomial. Now you're going to see why it's called a perfect square when you look at these coefficients, but we're going to do that later. Okay, so I think you can do this worksheet now. Look at all the problems, those 10 problems you'll be able to do, correct?
Okay.
Yeah.
Okay.
Just use the FOIL method. I just want the answer. I don't need to see the work. I just want the answer. But notice there are some with 2 variables in it, so make sure your answer has 2 variables. You do it quickly. Some of you do these things quickly. You forget to put the variable that needs to be there.
Do you want us to do it now and here?
No, not right now.
Oh, okay.
No.
This is homework.
Yeah. Let's do a week from today.
I assumed it was, but
Yeah, we don't have time to do stuff like that. You saw those sections we have to cover for the end of the semester? All right. Okay. All right. Okay, now let's look at this. So this is going to be on page, let's see. Okay, on page, we're on page 385. 385. 385. So section 6.1, the title is greatest common factor. We talked about the letters GCF. The GCF, so greatest common factor and factoring by grouping. And factor by grouping. Okay, that's grouping. It's not a difficult section. Okay, this thing keeps messing up. Okay. All right. Okay, so this is going to be number 1. I'm sorry, number 2 on page 385. So what they're asking you here, so we have 30, that's a 36 and 90. So what they're asking, and you need to know that because when we start factoring and you have these coefficients, you're going to find the GCF of those coefficients as well. Because the first thing you're going to do when you factor, when they say factor completely, first thing you're going to do is look for the GCF. That's step 1 always. Find the GCF. Okay? So in a previous course, in Math 97, you had to find the GCF of these two numbers. So let's kind of remember how to find the GCF. So the GCF means this, means greatest common factor. So the idea is this, what's the largest number that goes into 36 and 90? What's the largest number that goes into 36 and 90? That's what you want to find.
No.
You think 9? 9's the largest?
No.
wait a minute.
No. 9 is it's bigger than 9.
Yeah, so the greatest has to be as the largest possible.
Right.
So 9 goes into 36, right?
18.
9 goes into 36 though, right?
Yes.
And does 9 go to 90?
Yes.
Okay, and if someone comes back and says, well, no, 6 is the greatest, right away you know that's not true. Because 9 so far is bigger than 6.
You just do multiples of
Okay?
that.
All right. So someone said 18. Now you have access to calculator, correct? So let's check. Does 18 go into 36?
Yes.
Yeah.
Yes.
Does 18 go to 90? Let's see. 90 divided by 18.
You got
Yeah,
an error.
yeah, the thing's on error.
Oops. 90 divided by
Wow.
18. So it does, correct? So far, we think that 18 is the greatest common factor. Is 18 the greatest?
Yes.
Okay, 18 is the largest. So the greatest common factor is 18. Now, notice what you did last semester, though, or not last semester, but in Math 97, was that when sometimes these numbers are big. Now, for the most part, the ones that you're going to deal with, you can look at it and say real easily what the greatest common factor is. But what you did in a previous course in Math 97 was you used a tree. Remember the factor tree?
Yeah, where you broke it down.
So let's use the idea of a factor tree for right now.
2 times 18.
Hold on. So we're going to start with 36. So give me two numbers whose product is 36.
2 times 18.
2 times 18, 6 times 6,
9.
right? 9 times
Times
4.
four.
It does not matter. Someone said 6 times 6. Or what was the first one that was said? 18 times 2?
18 times 2, 6
Okay.
times 6, and 9 times 4.
Yeah, it doesn't matter though, right?
No, sir.
Okay. Now, when you do the factor tree, you want to circle your prime numbers. Because when we use a factor tree, we're writing these numbers as a product of prime numbers. Product of prime numbers. All right. So if you took 97, but this is a prerequisite for this, when you took 97, one of the things you learned at the very beginning of that course was how to write composite numbers as a product of prime numbers, and that's what this is. So I'm going to circle this right here, this branch. We think of this as a tree with branches. So this branch I'm circling because it's prime, right? 2 is a prime number. Is 18 a prime number?
No.
No, because I can factor it further.
2 times 9.
2 times 9. Are any of those prime?
Yes.
Yes.
2.
2 is prime. 9 is not prime.
The prime numbers.
Yeah, prime number is a number whose divisors are 1 in itself. 3 is a divisor, so it's not prime. How can I write 9?
3 times 3.
3 times 3. Are those prime?
Yes.
Yes. So 36, I can write, let's put it in numerical order. Look at the 2's. How many factors of 2's do you see altogether? 2. So 2 to the second times, and then 3 to the second. So that is your prime factorization for 36. So 36 is 2 squared times 3 squared. Now let's do 90. Do the same thing. 90 is 10 times 9, right?
45 times.
Or 45 times 2, or
I was going to do 3
there's a bunch of them, correct?
Mm-hmm.
I just went ahead and I did 10 times 9. Are any of those prime?
No.
No. So I keep on going. 10 is what?
5 times 5.
Those are both primes. 9 is what?
3 and 3.
Those are both primes.
Yes, sir.
So 90 is, let's put it in numerical order. So 2 times 3 squared times 5. All right. So from there, I can find the greatest common factor. The greatest common factor. All right. Now listen carefully to this. Remember, in the word common, in the phrase GCF is the word common, right?
Mm-hmm.
So whatever prime number I use has to be common to both. So let's start with the first one I see. I see the prime number 2. Is our prime number 2 listed here?
Yes.
Yes. So in my GCF, I am going to use the number 2. The question is, how many do I need? How many do I need? Okay. So how many do you see here?
2.
2. How many do you see here?
1.
1. So you think it's just 1, right?
You can only use 1.
Okay. Let's look at 3. Do I see 3 in both of them?
Yes.
Yes.
And they're both squared.
And they're both squared.
So you use both.
So you use both of them. So if this one was cubed, let's say 4th. I'm sorry. I don't want to use cubed because the number 3. Let's say 3 to the 4th. I have 2 here, 4 here. You use however they have in common. Because in the word GCF is the word common. So I have 2 here, 4 here. How many do they have in common?
2.
2. All right. If that was a 4, right?
Okay.
Okay. But it's not a 4. They're both 3 to the second. So I'm going to need how many?
Both of them.
Both of them. Now notice what's 3 squared?
9.
What's 9 times 2?
18.
There's the GCF. All right. So you learned that in a couple of courses ago. So, but for the most part, you'll be able to look at your expression, that polynomial, and you'll be able to right away determine what the GCF is.
Can you say what you said again about if that 3 squared was to the 4th? What did you say about that?
We remember in the phrase GCF is the word common.
Mhm.
All right. So if there are 3 2's here, I'm sorry, 2 3's. 3 occurs twice here, and let's say 3 occurs 4 times here.
Okay.
So I have 3 times 3, 3 times 3 times 3 times 3. How many 3's are in common in both of them? I have 2 here, 4 here. So altogether, how many in common? 2. Okay?
Okay.
So you use 3 squared. For the most part, I want you to notice though, so suppose you had this. I'll make this up for right now. Suppose we did all this work. And let's say this number 1 right here, whatever it is, let's say my prime factorization was 2 cubed times 3 to the 5th times 5. Okay? And let's say number 2 was 2 squared times 7 times 3 to the 4th times 5 cubed. All right, I made this up. So you did all that factorization, and you got that. And then the question is, what's the GCF of number 1 and number 2? If you look at your prime numbers.
2 squared.
So let's start with the 2. do I have 2's in both of them?
Yes.
Yes. I have how many factors of 2 here?
3.
How many factors of 2 here?
2.
How many do I need?
2.
2. Use the one with the smallest exponent. So GFS will be 2 squared times, do I have 3's in both of them?
Yes.
I have 5 here, 4 here. How many will I use?
4.
4.
3 to the 4th.
I have 5 and 5. How many do I use?
1.
1. I have a 7 here, none here. Do I use it?
0.
No, because they don't have it in common. So whatever this product is would be your GCF. Okay?
Okay.
All right. But what you look at in terms of exponents is the one with the smallest exponent or the largest? The smallest. Smallest exponent.
Square, huh?
You know what now?
You don't square, you just multiply.
What do you mean by, what do you mean I don't square? I don't square what?
So to get the pattern, like,
To get this?
yeah.
No, I mean you would. You would say 2 squared is 4.
4.
3 to the 4th. You would just do this. You would say 3 squared. 3 squared times 3 to the 4th times 5, right?
Mm-hmm.
So 3,645 is your GCF. Okay? 3,645, right? Now again, I made that up, right? Okay. All right? Okay. What now? What was that? Okay. All right.
If you need your calculator to multiply all that, you can.
Yeah, that's what we did. We just used a calculator to multiply this thing out. Okay, now let's look at number 6. You have 15, 25, and 27. So this now remember you're going to be dealing with polynomials, and so these polynomials can have 4 terms, 3 terms, 5 terms. They can have a bunch of terms, and those terms are going to have coefficients. And so let's say I have these 3 coefficients. You got to find the GCF of those coefficients. So what's the largest number that goes into 15, 25, and 27? This you can actually guess at without doing this work.
1.
No. Well,
So if you say 5, you better ask yourself, does 5 go into all 3 numbers? It does not. 5 does not go into 27 evenly.
no.
No, because 3 doesn't go into 25.
3 does not go to 25 evenly.
Well, this is funky-tated. I don't think sure this one.
Someone said the answer.
Well, it was just-
If you don't see a GCF, then the GCF is automatically the number 1. 1. So the GCF is 1. 1 is the smallest number. I'm sorry. 1 is the largest number that goes into both of those evenly. GCF is 1. 1. So if you look at the factor tree, now I'm not going to do the factor tree because you can tell me what the prime numbers are. 15 is what?
3 and 5.
3 and 5. 25 is what?
5 and 5.
5 squared. 27 is 3 times 3 times 3, which is 3 cubed. Y'all agree?
Mm-hmm.
All right. Now, 3 times 3 is 9, 9 times 3 is 27. Okay. Now, remember, greatest common factors, what do all have in common? I see a 3. Is there a 3 in all of them? No. I see a 5. Is there a 5 in all of them?
No.
No. So right away, the GCF is only what number?
1.
1. GCF is 1. Okay. Now, in your polynomial, you're also going to have variables. Okay? So let's find the GCF of this. This is going to be number 8. X cubed, x squared, x to the 5th. Now, before you go any further, I want you to remember what we just talked about. We talked about on the previous page that to find the GCF, you look at the one that has the smallest exponent. Okay? So if I look at this right here, there are 3 factors of x, there are 2 factors of x, and there are 5 factors of x. Now, my question to you is this. Is the GCF 1? No, because all of them have an x in common, right? So I'm going to have at least one x. What do you think the GCF is? X squared. Okay, that's that. All right, let's look at number 12. You have p to the 7th, q, that's a 7. p to the 7th q, that's your first one. P to the 8th q squared, comma, and then p to the 9th q cubed. All right, think about what we talked about a while ago. All these that I give common and then the smallest exponent. So let's look at the p's. Do I have p's in all of them?
Yes.
So what's going to be the GCF of the p's?
7.
P to 7. Do I have q's in all of them?
Yep.
So what's going to be the GCF?
1.
Q to the
First.
first. Okay. So what's the GCF?
P to the 7th cube.
P to 7q. All right. 16. You have 32 x to the 5th, comma, 18x squared. Do the coefficients first.
8. Oh.
So look at 32 and 18 first. What's the GCF of 32 and 18, do you think?
That's an 8 on Q.
32x to the 5th, 18x squared. 32 and 18, what do you think the GCF is?
2.
Okay, you think it's 2?
Yep.
All right. So they're both even, right?
Mm-hmm.
So 2 has to be at least one of them. So let's look at 32 for a moment. 32 is 16 times 2, right?
Yes, sir.
Okay. 16 is 4 times 4, or 8 times 2, right?
Yep.
4 is 2 times 2. 4 is 2 times 2. Y'all agree? And all these are what?
Prime.
Prime. So 32 is 2 to the 5th. Good. 18 I can do in my head. 18 is 9 times what though?
2.
2. And 9 is 3 times 3.
So 3.
So that's 2 times 3 squared. Y'all agree? So this is 2 to the 5th. This is 3 squared. Now here's a question. In my GCF, will I use a factor of 3?
No.
No, because 3 is not in this one. Will I use a factor of 2?
Yes.
Yes, because 2 is in both of them. I use the one with the smallest exponent. That's a 5. That's a what? A 1. So I just need a 2. So if you say the GCF was 2 is correct. So the GCF for this one, though, will be 2 what?
X squared.
X squared. All right, good. Number 20. Okay, 20 you have 15y squared, comma, 5y to the 7th, comma, and then negative 20y cubed. All right, now, unless they tell you otherwise, you see how in all the others we've done, the coefficients were positive numbers? You have one that's negative, right? Unless you're told otherwise, your GCF is going to be a positive number. So it'll be positive. So what's the greatest common factor? What's the largest number that goes into 15, 5, and negative 20?
5.
5. Nothing else. Right? All right. But remember, when we did 32 and 18, you really look at your smallest number. What's the smallest coefficient here? 18. And so you ask yourself, what numbers go to 18? And let's look at the largest. What's the largest number besides 18 that goes into 18? 9. And the question is, does 9 go into 32?
Absolutely not.
No. Then what's the other number that goes into 18 evenly?
2.
Yes, 6 and so on, right? So 2, and you eventually get down to 2. 2 goes in 18, 2 goes in 32, so the GCF has to be 2. Over here, what's the smallest number?
5.
What are the factors of 5? It's only 1 and what?
5.
5. So the only thing you can check is this 5. So there's 5 going to all of them. Yeah, so the GCF of your coefficients are what? 5. So GCF will be 5, and then what?
Y squared.
Y squared. That's a 2, a 7, and a 3. All right, now let's look at 20. Now let's do 24. Okay, 24. All right, 24, you have this. You have 40, x to the 7th, that's a 7, y squared z, comma, 64 x to the 9th y. The variables are easy. The coefficients, when they're becoming a little bit larger, that's 40 x to the 7th y squared z, comma, 64 x to the 9th y.
The variable's 8.
Okay, so what's the largest number that goes into 40 and 64 evenly?
8.
Anybody else? 20? You're telling me that 20 goes into 64 evenly? Can't be 20. What do y'all think? Does 9 go into 40 evenly?
No.
8, right? It's 8. So the GCF is 8, and then what are your variables?
X to the
X to the 7th,
Y.
y.
Z.
No, because you see how the 64 doesn't
You
have
can't
the
use a
Z?
Z.
That's right.
The 64
Can't
doesn't
use a
have
Z.
it.
Because here it's in the phrase GCF is a phrase common. Z is not common to both, so you can't use Z. All right, so the GCF will be 8 x to the 7th y. So that's an 8. Okay. All right. Let's look at. All right. Now, so in those questions, you're asked to find the GCF. That's all you're asked to do. Okay. Now the next set's going to say factor out the GCF. Factor out the GCF.
See, this
Factor
is where
out the
it starts to
GCF.
get just a whole cluster of BS, in my opinion. Not to insult your professor. But
All right. To each his own.
Oh yeah.
18a plus 12
18a
plus 12. Okay, so listen to this carefully, though. All right, so we have this binomial, right? And so I want to factor out this GCF. So when we do factoring, and this whole chapter deals with factoring, and anything after that is going to involve factoring. So for the most part, 90% of what you can do from now on is going to involve some kind of factoring in here. And also a lot next semester. So if I were to write these two, how many terms do you see here? 2. So if you look at 18a, comma 12, what's your GCF?
That's something that goes immediately into the first thing I think of would be 6.
6 only, right? Or is it 6a?
No.
No, because there's no a in the 12. So the GCF is just what? 6. But you didn't have to write it like this, like these were. You could just look at these two terms and ask yourself, for 18 and 12, what's the greatest common factor? 6. I can't use the letter A because A is not in where?
The 12.
That one. So GCF is just 6, right? Okay. GCF is 6. I'm going to write that down. GCF equals 6. Now you got to, when it says factor out the GCF, you're gonna think of the distributive property. So do y'all agree that when I factor out the GCF, that's the same thing as saying 6 times, think of the GCF. So you're gonna put the GCF out in front. You're gonna put the GCF out in front, and you're gonna think of the distributive property.
Yep.
6 times what is 18a?
3a.
3a. Plus 6 times what is 12?
2.
And there's your answer. So you factored this. You factored this completely. So you factor this problem by taking out the GCF.
So basically, we making it into like a longer equation.
That's not an equation.
Well, a longer
Expression?
We making it from a shorter expression to a longer expression.
No, because I wouldn't think this is longer than this one. You're writing it as a product. Factoring means to write as a product. So you're going to take this right here and you're going to write it as something times something. So 6 times 3 plus 2. Factoring means to write as a what? Product. So you better take this and write it as a factor times another factor.
And you only use the variable on side and then
Only use the what now?
the A, like you only use the X's in the A.
I only use the A because there's an A. Is that what you're asking?
Yeah, like,
According to distributive property, 6 times what is 18A? 3A. 6 times 3A is 18A. 6 times 2 is 12. That's distributive property. Okay, that was something that we talked about at the beginning of class, and also you had last semester, the distributive property. Okay, so let's look at number 30. You have y to the 5th plus 6y to the 4th. Y to the 5th plus 6y to the 4th. You have to be able to look at this polynomial and determine what the GCF is. What do you think the GCF is? Anybody else? You all agree it's y to the 4th? It may not be. I'm just asking.
Yeah.
I don't agree, but I'll probably be wrong.
What do you think it is?
I think, how can you factor y into 6y? Like, it's two different exponents.
Well, y, there's an understood one. If you have a y and you have a 6y, I mean, y times 6 is 6y. Or 6 times y is 6y.
Like, the basis, but both expressions the same y.
Yeah.
I understand it. So it's still gonna be factored if the 6 is in front of one of the y's.
So first of all, you understand that the GCF is y to the 4th. That was what we've been going over all of these right here.
Yeah.
Okay, so you understand that part. All right, so that's good. At least you're that far. All right, GCF is y to the 4th. So then you're gonna write. It says to factor it out. So you're gonna think of the distributive property. So you're gonna put y to the 4th in front of this parentheses. Okay, y to the 4th, and then distribute. Y to the 4th. You learned that last semester. Y to the 4th times what is y to the 5th? Y. Multiply like bases. You add exponents. Plus y to the 4th times what is 6y to the 4th? 6. And that's it. Y to the 4th times 6 is 6y to the 4th. That's all you did. There's your answer. Distributive property. You have to have the distributive property to be able to do this. You understand? Okay, that's why we went over it. You did quite a few of this last semester, but the distributive property, there's your answer. That's whatever you have in front of that parentheses better be your what? GCF. What? Doesn't matter. You know it now. Okay? You gotta. It doesn't matter how long ago you took this though, guys. I understand that you may have not been here 10 years or 5 years, but it's still a what? Prerequisite to this. Okay? So you got to do whatever you got to do to understand this. Okay? I understand you may have been out of here for a while, but it's still prerequisites that are needed. So that just means that you as an individual have a lot more to do than someone else that may have just taken this last semester. Okay? There's nothing I can do except teach the current standards for this course and then review some things, which I've done with those 2 first worksheets. Mm-hmm. Okay. 34. You have 7x plus 21y minus 7. 7x plus 21y minus 7. How many terms do you see?
3.
3. All right. Now, if you want to put them in commas like we did the previous problems, you could do this. My terms are 7x, comma, 21y, comma, negative 7. Look at the numbers first. In all 3 terms, there's a 7, a 21, and a negative 7. What's the GCF?
7.
7. Very good. Look at your variables. Do I have a common variable in all of them?
No.
No. Very good. What is the GCF?
7.
7. All right. Awesome. Now, since I know it's 7, and in the direction says factor out the GCF, which you're going to need, it's not always going to say do that first. You're going to have to know at some point that the first thing you always have to do is factor out the GCF. So it's 7, right? Mm-hmm. So you're going to say 7 times whatever's inside the parentheses that needs to be there. I had how many terms here, though? I bet I have how many terms in here? 3. 7 times what is 7x?
X.
Very good. 7 times what is 21y?
3y.
7 times what is 7? All right, so there's your answer. So the answer is 7 times x plus 3y minus 1. Distributive property. That's all that is. Distributive property. All right. 36. 36. Let's look at 36. Okay, 36. You have 12x cubed plus 16x squared minus 8x. Look at the coefficients first. 12, 16, and 8. What's the GCF of those?
4.
4. Don't say 8, because 8 doesn't go into 12 evenly. But what's the largest number that goes into all of them?
4.
4. All right. So far, my GCF has a 4. Do I need a variable? Yes, because x isn't common to all of them. I use the one with the smallest exponent, which is just x. So the GCF is 4x, right? So my GCF is something other than 1. It's 4x. That means I can write this as 4x times whatever goes inside the parentheses. Distributive property.
So
4x times what is 12x cubed?
3x squared.
Very good. And you can check. 4 times 3 is what?
12.
12. X times x squared is x cubed. Plus 4 times what is 16x squared?
4x.
4x. And you can check. 4 times 4 is 16. X times x is x squared. Minus 4x times what is 8x?
2.
2 only. Very good. And that's it. You're done. So you factored this thing. All right. So remember, factor means to rise a product. And I did. I rose a product. It's the GCF times this polynomial. All right. Okay. Now, let's look at number 40. Number 40. So in 40, you have 9y to the 6 minus 27y to the 4th plus 18y squared plus 6. So 9y to the 6 minus 27y to the 4th plus 18y squared plus 6.
GCF is 3.
All right. It's just, there's no variable, right? Because the 6, this constant, what now?
No,
There's no variable because that's a constant to begin with, right? You don't see a variable, so you better not have a variable in your GCF. Because remember, greatest common factor, you see the word common. Y is not common to all of them. But what is a GCF?
3.
3. GCF is 3. So you can say 3 times, how many terms goes inside the parentheses? 4. 3 times what's 9y to the 6?
3y to the 6.
Minus?
9.
You have 9.
9y to
The 4th, right? Plus?
6y squared.
Plus?
2.
2. Okay. All right, so there's your answer there. So you factor this, you wrote as the GCF times the polynomial. All right, now you're going to have a fraction, so let's look at 42. I don't think I had a fraction on the worksheet. I don't think I did. But you are going to see it. You are going to see one on my math lab. So let's look at 42. You have 2/5 y to the 7th minus 4/5 y to the 5th plus 3/5 y squared and minus 2/5 y. Okay, it's not that bad because if you look at the denominators are all the same. They're 5. So you're gonna have at least the GCF being a 5th.
Oh, thank goodness.
So look at the numerators though. A 2, a 4, a 3, and a 2. What's the GCF of those numbers?
1.
1. So what's the GCF of 2/5, 4/5, 3/5, and 2/5?
1/5.
1/5.
Oh, yeah, 1.
Okay, now look at the y's. Do you have y's in all of them?
Yes.
So how many do I need?
One.
So what's the GCF?
1/5 y.
1/5 y. Okay? So the ones that you have will be, the denominators are the same. All right, so the denominators are the same, it's easy. If they're not the same, which you're not going to be given that here, but if they're not the same, you'd have to find the GCF. Not the GCF, I'm sorry, the least common denominator. Least common denominator. You have to do that. All right, but it will be the same. So all you have to do is just find the GCF of the numerators.
Can you show us that
Show us what?
with the LCD?
No, I don't want to waste the time if it's not on the worksheet or my math lab, but I can show you if you can stay after class or come back early next class period. But it's not on the worksheet or my math lab. Okay? All right. So you're going to say 1/5 y, but you really, it's not too bad not to know this. I mean, all right, 1/5 y. Now it's going to be a little bit harder for some of you if you don't remember how to multiply fractions. 1/5 y times what? Well, let's do the 1/5. 1/5 times what's 2/5?
2.
Good, 2. Y'all agree? Just 2. 1/5 times 2 is 2/5. Y times what is y to the 7th?
Y to the 6.
Y to the 6th. Minus 1/5 times what's 4/5?
4.
4. Y times what is y to the 5th?
Y to the 4th.
Okay. 1/5 times what's 3/5?
3.
3. Y times what is y squared?
Y.
Minus 1/5 times what's 2/5?
2.
And then y times what is y?
1.
1. So 2 times 1 is just what?
2.
2. So that's just a 2. Y'all agree that 1/5 y times 2 is 2/5 y?
Mm-hmm.
Okay. All right. Okay, now. Okay, so we're not done, but let me just give you the worksheet so far.